Sorry guys, my video kind of got cut off. My computer died, but I'm back. Okay, so what we were doing was we were going into our calculator and we were going to see what happened after 5 years. So I have 1,000 and I'm multiplying by 1.05 to the fifth power. And that was $1,276.28. Is that right? Okay. So again, just like I did last time, I'm going to kind of make a little bit of a table here and get some other values. So I know I'm starting at 1,000 and I'm going to use my calculator to get a couple more. I'm going to see what happens after 1 year, after 2 years, after 3 years. So I have 1050. I have 1,102 and 50 cents and 1,157 and 63 cents. I'll skip 4. I know what 5 is. Okay, so let's see. If I do 1,000, and then I can do 1,100, 1,200, 1,300. So there's where I'm starting. After 1 year, I'm halfway. 2 years, I'm right above 1,100. 3 years, up to 1,157, so a little over halfway. I skipped 4, and then 5, I'm at almost at 13. So I see more of curving like this. Sorry, my drawing is awful. So since my drawing is so awful, let's look at what this looks like in the calculator. That might be a little bit better of a representation. So I have 1,000, 1.05. I got to do the x power on this, not t, just because it says f of x. Got to match that variable. Of course, I'm not going to see anything because these numbers are a lot bigger. So I'm going to zoom out a little bit. Not really what I want to see. Let me change my window. So I really don't need to see all that negative on the x because this is time. So I'm just going to start at -1 and go to 6 so I can see all of my... I don't need to see the negatives. Again, this is money, so I'm just going to start at 0. And then my highest y value was at like 1,200, so I'm going to say 1,500. Here's a little bit better. Doesn't look super curvy, but we have a pretty low interest rate there. Okay. Number 8. Write the equation of the asymptote, the domain, and the range for each growth or decay function. So I'm actually going to start with growth or decay. What I'm looking for is the growth rate here, and that is right there and right there. So since 3 is bigger than 1, we're going to say this is growth, and 1/3 is less than 1, so we're going to say decay. On C, it's pretty easy to see that it's growth. It's going up from left to right. And actually, D is neither. This is actually a growth that is reflected down over the axis. So I'm not really going to say that this is growth or decay because it's a reflection over the x-axis of a growth. So asymptote. This plus 1 means that my graph of 2 times 3 to the x is shifted up 1 unit. So just 2 times 3 to the x is going to have a y-intercept of 2. And triple, so 1 would be at 6. But that plus 1 means I'm going to move this graph up 1 unit. So my y-intercept would now be at 3. And my asymptote would be here at 1. Your asymptote always matches whatever's adding or subtracting. Y equals 1. Now my domain every single time is all real numbers from negative infinity to positive infinity. And my range is from 1 to infinity. Or sometimes you'll see the range written as y is greater than 1, that it's 1 and above. Number 2. This would be the graph. It starts up here at 10 as the y-intercept, and it decays by a third every time. But this minus 2 means I'm shifting my graph down 2 units, so then it would start at 8, and it would decay down. This asymptote would be at y equals negative 2. Again, asymptote always matches that number that's added or subtracted onto the end. Again, my domain is from negative infinity to positive infinity, all real numbers, and my range is y is greater than negative 2. Or you can see it written as negative 2 is less than y is less than infinity. In C, all I've got to do is look, where is this imaginary line that my graph is getting close to and approaching, and that would be at y is equal to negative 3. Same domain every single time. My graph goes on and on and on and on this way, and on and on and on that way. My range is going to be y is greater than negative 3, or the other way is negative 3 is less than y is less than infinity. The reason why I put this D on here is because I wanted you to see when the range is not greater, because you see that in all of these, y is greater than 1, y is greater than negative 2, y is greater than negative 3. So I didn't mean to confuse you about the growth and decay, that this is a growth that's reflected, but asymptote here is at 1. Domain is the same. I wanted to show you this range. So we're going less than 1. All the y values are less than 1. So we could say y is less than 1, or positive infinity, negative infinity is less than y is less than 1, because we're going down. We're not going up and up and up forever. So just see how this is written backwards. It always goes from least to greatest. Okay, just filling in the blanks for some word problems. The function 180 times 1.3 to the x represents the balance in a savings account after x years if blank was initially deposited and the growth rate is blank per year. So we're just looking at these two numbers. The initial value is always in the front. So $180 was initially deposited. And remember, a growth is 1 plus r. So what decimal got added to 1? That would be 0.03. Converting that into a percentage makes that 3%. A radioactive isotope. Oh, I'll finish the next one in the next video. It's about to end.